section 1-3. This is like the second half. I did this on purpose. Okay, the first half was about the distance formula. The second half is about something else. And I purposely split it into 2 days because I didn't want you to get confused between the two in one class period. All right, so we talked about the distance formula. We went over the homeworks on that stuff, so hopefully you got that clear. So the thing that we're doing today is we're not finding the distance between 2 points, but we are looking at 2 points. They will give you 2 points, but you're not finding the distance this time. You're going to find something else, which is the midpoint. Alright, and we call this the midpoint formula. Alright, remember yesterday we talked about being on the road and going to McDonald's and all that stuff?
You did?
Well, at least I did. Whether or not you were awake and paying attention, that's another story. But I talked about it. Look it up on YouTube and you can see it. So watch. We use these numbers. I'll use the same numbers we used yesterday. We used 20 and 50, right? And here's where McDonald's was. Remember that? And we wanted to go from here to McDonald's. So we wanted to find that distance. So how did we find the length of that line, or how did we find the distance that was traveled? We subtracted, right? We went 50 minus 20, and we got 30, and that was the length. That's how far we traveled from here to here, was 30 miles. We're not doing that today, though. We're doing something else. Let's take that McDonald's and move it about right here. So let's say here, we're changing our scenario a little bit. So everybody listen, please. So we change our scenario. We're not going from one point all the way to the end. What we're going to do is think of this. Say your friend lives at the 20-mile marker and you live at the 50-mile marker, and you want to meet for lunch. But you don't want to travel 30 miles to meet the guy for lunch or girl. Okay? So you want to meet halfway, right? You want to meet at the what? At the midpoint, okay? M for McDonald's, M for midpoint, whatever you want to use, okay? So you want to meet midway or halfway. So that's what you got to figure out, okay, what mile marker are we going to meet at? All right? What exit is that McDonald's out at if it's halfway in between? There's a couple ways you could do it. This is the way a lot of people think about this. They say, okay, well, what's the total distance? We already figured that out. What was that? It was 30, wasn't it? So the whole distance was 30, but we want to go how far? We want to go halfway, don't we? All right, so let's say this person right here started from here. If they went 15 miles, where would they end up? At McDonald's, but what mile marker? At the 35-mile marker, that's right. Okay, at the 35-mile marker. Or this person right here can go the opposite direction, 15 miles, and where'd they end up? All right, at the McDonald's, but at the what mile marker, though? That's what I'm concerned about. At the 35-mile, okay, mile marker. All right, that is the midpoint. That's halfway, because look, they both went 15 miles, agreed? But what I want you to do is this. That's one way of doing it. It's not the way that we're going to look at it, though. I want to look at it a little bit different way. And this actually, you know what, I'll keep that 35 right there. Let's do this. Look at the 20. See if you can get to 35 a different way. Instead of subtracting, because look, we would have had to go 50 minus 30 is what? I'm sorry, 50 minus 20 is 30. Half of 30 is 15. Then you would have to add it. So that's really 3 steps. I can actually get this number in 2 steps instead of 3 steps. And that's better, isn't it? Don't you think? Doing it in 2 steps rather than 3. So look at this 20. Look at the 50. What can we do to those 2 numbers to get 35 in 2 steps? Say it, Jada. You got it. What's that? Okay. If you add them, do you get 35, though? So, but if I add them, she's on the right track. If I add them together, what do I get? I get 70, but that's not that. Divided by 2, because it's halfway. That's right, okay? If you divide it by 2, then you've got the halfway point. So watch this. I'm going to take that. In an algebra, we show division like this most of the time. So we divide it by 2. So look what we get. 20 plus 50 is 70. Divided by 2 is what? 35. So actually, we did it in 2 steps. What was our first step? We did what? We added. We added the what? What do we call these points on the end? Endpoints. Very good. Okay, so we added the endpoints, and then we divided by 2. Why did we divide by 2? Is that just a arbitrary number, a random number? No. This halfway point. If you divide by 2, you're getting halfway, aren't you? It's kind of like finding the average, isn't it? So if I give you 2 numbers, if you get 2 test grades, let's say you got a, well, hopefully these aren't test grades, but let's say you had a 20 and a 50, and you wanted to find your average, what would you do to find your average? You add them up, divide by 2, right? And that's what you're doing here. To find the midpoint, it's kind of like the average of the two endpoints. You hear what I'm saying? That's very, very helpful to you if you can understand that. Okay, to find the midpoint, it's the average of the two endpoints. You add them up and you divide by 2. Now that's just going in one direction, isn't it? What if our line was slanted instead of just going horizontal like that? We talked about this yesterday, didn't we? Let's pick another color. Let's go yellow. All right. What if I had a point right here and a point right here? I won't even number the points. We'll just draw a line in between them. Now here's the question. It kind of looks like the question that you did yesterday. It kind of looks like the distance problem, but we're not finding the length of the line this time. It's a different question. It's not the same question. So what are you doing to that line this time? You're finding the what? The midpoint, okay? Let's just kind of guess where it would be. It'd probably be around here somewhere. That would be my guess, wouldn't it? Something like that. So that's what we want to find right there. Now watch this. This point right here, we'll call x1, y1. Kind of like what we did yesterday. This point right here would be x2, y2. Alright? What we want to do is find the midpoint. So, what do you have to do? Well, you got to go halfway across this way and then halfway down this way. Everybody see that? So we're actually finding the midpoint of two things. We're finding the midpoint of the y, which would be about right here. We're finding the midpoint of the x would be about right here, and then look what we're going to do. Look where it's going to end up. If we go halfway along the x and halfway up and down the y, it's going to end up at our midpoint. So how do we find halfway across the x? Well, yeah, do what to the x's? Add them up. So you add up the x's and divide it by 2. How do we find halfway up and down the y's? Add them up and then divide by 2. And there it is. That's your midpoint formula right there. I'll put MP for midpoint. That's how you find the midpoint. Very, very simple. Now notice what it is. It's not just a length. It's not just a distance. What is it? It's a parentheses with a comma in between. So it's a what? It's a coordinate, or it's a point, right? Or it's an ordered pair. Exactly right. So when you find the midpoint, you're finding a point, an ordered pair, a coordinate. That's what you're finding. You're not just finding the length or the distance, right? Like we did earlier. And I say that for a reason. You're probably thinking, he just keeps repeating himself all the time. The reason I repeat myself, because I've seen so many students in the past, you'll see a problem where it says, find the midpoint, and then their answer looks like something like that. Does that look like a midpoint? No, that looks like a length. That looks like a distance. What's a midpoint look like? It looks like an ordered pair, doesn't it? Like 2, 3. That looks like a midpoint. Would you agree? That looks like a point. Okay? If you write an answer, if it says, find the midpoint, and you say, oh, it's 7. That doesn't make any sense. Because that's not a point. That's just a length. That's just how long something is, okay? So that doesn't make any sense. This, it's got to look like a point. I can almost promise you that some of you guys are just going to do it's going to say find the midpoint, and you're going to write down an answer like this. And why do I promise you? Because I've seen it in the past so many times. All right, even though I beg and plead with my class to make sure when it says find the midpoint, you write it as a midpoint. All right, I hope I'm making it clear. It would be really nice if you broke the trend. All right, and when I ask for a midpoint, at least you write it as an ordered pair. At least do that much for me, okay? So here we go. Let's do a problem. All right, here's a problem from the book. It's one of the examples. Yeah, let's do this. Here's point E, and they say point E is negative 8, 6. All right, and they also tell you point P, which is negative 5, 10. And they're going to ask you to find the midpoint of these 2 points, okay? Now, do you have to graph these things? Do you have to make an X and Y axis and draw all your pictures? No, you don't have to. You got a formula right there. It's called the midpoint formula, all right? There we go. Get it on the screen. All right, that's the midpoint formula. This is what we're going to use to find the midpoint. So let's do this. Remember, it's an ordered pair. So the first thing I do is I put my two sets of parentheses and I put a comma in between. That's what you do when you find the midpoint. How do I find the x part? I add the x's together and divide by 2. So let's do that. Let's take the x's. Which ones are the x's here? First ones, right. -8 plus what? -5. Good. And then you do what? Divide by 2. Then you do the y's. Which ones are the y's? The second one. So this is 6 plus 10, and you divide that by 2. And now you just simplify it, and you're done. That's all there is to it. It's actually pretty easy. So let's add them up. -8 plus -5, that's -13 over 2. Now, if it comes out as a fraction, just leave it as a fraction. Don't take this and turn it into a decimal. Don't even turn it into a mixed number. Okay, I would just keep it exactly like that. Let me see something. Oh, okay, I was looking at another problem, but all right, and then this is what? 16 over 2. Can we just do that in our head right now? 16 over 2 is what? Just 8, all right? And then there it is. Just leave it like that. Don't change that to a decimal. Don't change it to a mixed number. Just leave it like that. That is a perfectly fine answer, just like that. That's how you find the midpoint. Yes? If it comes out 0, yes, absolutely. Put a 0 in for that. Right, don't just leave it blank because you need an x and you need a y. So if one of them comes out to a 0, absolutely put the 0 in for there. Don't just leave it blank. Okay? It wouldn't be wrong, okay? But look, it wouldn't be wrong. Well, if you said 6.5, it would because it's -6.5, right? It's -6.5. But it wouldn't be wrong if you wrote -6.5. I'm not saying that that's wrong. I'm not saying it's wrong if you put -6.5. But look, students question me on this all the time, and I don't understand why you would want to change it to this. This is already done. It's already finished. You don't have to do anything else, okay? The less you have to do, the better, as far as I'm concerned, don't you think? I would just keep it like that. I don't see any reason why you'd want to change it to this for an answer on a quiz or a test, all right? I would just keep it like that. That's perfectly fine. Now, if you wanted to graph it, it'd be a different story. If I said graph the midpoint, -13 over 2 doesn't really click in your mind, doesn't it, where it's located? So yeah, if you were to graph it, sure, you would write it like that. Okay, but I'm not asking you to graph it. I'm just asking you to come up with an answer for the midpoint. So just keep it like this if it came out to a fraction. Sometimes they come out nice and even, like this one did. But this one right here didn't. Just keep it like that. That's all I would do. All right? What do you think? That's not so hard, is it? Now, what we're going to do tomorrow, I thought about trying to squeeze it all in today, but I think what we'll do tomorrow is this. Now watch this. I'll just give you a little sneak preview of what we're going to do tomorrow. You guys paying attention? Watch. What I'm going to do is this. I'm actually going to give you the midpoint. All right? I don't know. Let's say it's 5, 4. And then I'm going to give you one of the endpoints. Let's say that's... John.
Sorry, I mean...
Let's say it's 9, 6, okay? Now watch. You guys paying attention? I'm going to give you the midpoint, and I'm going to give you an endpoint, and what I'm going to get you to do tomorrow, and this is a little bit more difficult, all right? So I wanted to give you one day, at least for the midpoint thing to sink in a little bit. And tomorrow, what we're going to do is we're going to find that other endpoint. So I'm going to give you the midpoint, give you the endpoint, and we're going to find the other endpoint, okay? So we'll do that tomorrow. So what we're doing today on the worksheet is up to 18, I believe. Yeah, we're doing 18. So we're doing number 13 to 18. So it's only 6 problems. It's midpoint. So it's the same worksheet, same exact worksheet as what I gave you yesterday, but you're doing up to 18. 19, 20, 21 is a little different. It's the stuff we're going to cover tomorrow. So you're only doing up to 18 today.